Okay, guys, so let's get underway. What I want to do with you before we get into the work on compound angles and double angles is I want to do some revision on what we need to know from grade 11. Because our reduction formulae and a few our cofunctions and a few other bits and pieces are really important. The other thing as well that's important going into matric for those of you that haven't finished Trig or haven't started Trig, or even those of you that have completed the section in Trig at school, the questions that we get are the same. So we get questions on Pythagoras, we get questions on ratio in terms of a letter, we have to prove identities, we have to do general solutions. So the types of questions that we get in Trig are identical to the types of questions that we saw in grade 11. But we include new information. So that's compound angles and double angles. So first we have to learn about compound and double angles. And then once we have learned about those, then we look at how this new information is incorporated into these questions that we have seen before. So today's lesson is a revision of what it is that we're also supposed to know. And then I'm hoping to be able to revise a question on Pythagoras and a question on ratio in terms of a letter with you as well, depending on how our time goes. Okay, so let's just have a look in the chat. Didn't finish maths last week, Friday. Mihlali. I wrote a test on inverse functions and it went well, I must say. I would always leave questions open, but I left. Oh, that's awesome, Mihlali. That's so nice that you felt confident to be able to answer everything. And I think, that's something that's very important for us in maths as well. Even if you are really not sure about an answer, you should always try and write something, because you never know whether the little bit that you do write, whether you're able to get a mark for that or not. I mean, if you leave it blank, you can never get any marks for anything. So yeah, it's really important just to try and write something. But so nice for you, Mihlali, to walk out of there and actually think, or actually believe that you had the confidence to answer everything. I'm so, so pleased for you. That's brilliant. Okay, so please do share your results with us. We would love to know how you've done. Shane, if you are struggling a little bit with internet today, don't stress. Remember, it's being recorded, and then you can go and watch the recordings as well. Remember, last year's lessons are also recorded, so those are all available to you guys as well on watobe.com. Okay, let's jump in and start talking. No problem, Shane. Let's start talking about the Cartesian plane. This forms the basis of our reduction formulae, our cast diagram, etc., etc. So let's just get some labels on the page. So that's X, that's Y. We know that this is quadrant number 1. We know that this is quadrant number 2. We use Roman numerals. We know that this is quadrant number 3. And we know that this is quadrant number 4. Okay. Other thing that's important for us is the signs of our coordinates in the different quadrants. So in quadrant 1, X is positive and Y is positive. In quadrant 2, X is negative and Y is positive. In quadrant 3, both X and Y are negative. And in quadrant 4, we would say that X is positive and that Y is negative. So it's very important to remember that X and Y change sign depending on which quadrant we are working in. Okay, especially when we're doing questions on Pythagoras. Okay, X and Y change sign depending on the quadrant. The other thing that we have assigned is over here, we say that that is 0 degrees. Here, we say that that's 90 degrees because it's made a right angle. The y-axis makes a right angle with the x-axis. This is then 180 degrees. This is 270 degrees, and this goes back to 300 degrees, which is a full circle. So what I am referring to is a terminal arm. Okay, and the terminal arm is anchored at the origin, like the hand of a clock. And before it has been moved in any direction, it is lying here on top of the x-axis. So if we elevate it into the first quadrant, we would say that this angle that has been created between the x-axis and the terminal arm, I could refer to that as theta. Okay. The terminal arm doesn't just come to rest in the first quadrant, though. It can come to rest in the second quadrant or the third quadrant or the fourth quadrant. It just depends, okay? If, for example, the terminal arm comes to rest in the third quadrant, essentially, again, I'm just going to do this in green. I'm going to write over this. So the terminal arm, let's say it's lying over here, and now it gets elevated, and I go in an anti-clockwise direction, and now it comes to rest over there. This angle over here is seen as our angle of inclination. All right, so maybe what I could do is I could refer to that as beta. All right, so theta can be an acute angle, it could be an obtuse angle if the terminal arm comes to rest in quadrant 2, or it can be a reflex angle. Right, it just depends on the particular question, okay, on the interval that they give you. All right. The other thing that is important to note is that if my terminal arm again is lying back on top of the x-axis and I move it in the opposite direction, so in other words, I go in this direction. If I go clockwise instead of anti-clockwise, here I would say that angles are negative. That's the definition of a negative angle. So in maths, we use plus and minus to differentiate between direction. So plus is one direction and minus is the opposite direction. Because angles get bigger in an anti-clockwise direction, that's why we say angles are positive. Okay, if we're going from 0 down to 270, essentially what we're doing here, Matrix, is that we're starting at 360 and we are reducing our angle to 270. Okay, so that's why we are allowed to look at 270 as minus 90. It's the same thing. Okay, does that make sense to everybody? Are we all happy so far? Thumbs up, thumbs down. Are we all good? I'm going to move on and start talking about the reduction formulae now. All right. So this is stuff that hopefully we are all familiar with and we know. Okay. Let's jump into our reduction formulae. Okay. So when we are reducing, we're using a reduction formula to write any angle in terms of an acute angle. So for example, okay, and I'll come back to the reduction formula now. If I am talking about the sine of 150 degrees. 150 degrees is an obtuse angle. I can use reduction formulae to write sine 150 as an acute angle. That is the function of a reduction formula. So in other words, what I would do is I would say that 150 is the same as 180 minus 30 degrees. So this then reduces to positive sine 30 degrees, for example. Okay, so I'm using my reduction formulae so that I can write an angle that was initially obtuse as an angle that is acute. That's the point of our reduction formulae. Okay, so the reduction formulae that you are required, and then obviously this would be a special angle, but anyway, we'll come back to those later on. So there are three normal reduction formulae that we use, okay? So if we're talking about an angle theta, we don't need to reduce it. If we are in the second quadrant, we would say 180 minus theta. That's because our terminal arm was here at 0. We went 180 degrees in an anti-clockwise direction and then theta degrees in a clockwise direction. So that's how we come to rest in quadrant number 2. That's why we use this as our reduction, as the size of an angle in the second quadrant. Here, this would be 180 plus theta. That would be for quadrant 3. So in other words, our terminal arm goes 180 degrees in an anti-clockwise direction, and then theta degrees forward into the third quadrant. And when we are in the fourth quadrant, we use 360 minus theta. So in other words, the terminal arm has done a revolution, and then it's come backwards this way into the fourth quadrant, okay, and come to rest there. Do not make up your own reduction formulae, okay. You're only going to use 180 minus, 180 plus, 360 minus, or 90 minus and 90 plus. 270 minus and 270 plus do exist, but that lies outside of the CAP syllabus. We don't use those. Okay, so do not use 270 minus to describe the third quadrant or 270 plus to describe the fourth quadrant. Okay. Was it Kia, Reabetswe? Please repeat the function of a reduction. So in other words, what you're trying to do, Reabetswe, is you're trying to write an angle in terms of an acute angle. So in other words, I'm taking an obtuse angle like 150 and I'm writing it in terms of an acute angle like 30. That's the point of a reduction formula. Okay. Or if I had something like the cos of 225 degrees. Okay, so Ria Betsway, if I said 225 degrees, which quadrant am I in? Cos 225, which quadrant am I in? Exactly, I'm in quadrant 3. So which reduction formula must I use? Yes, quite right, Jade. I'm in the third quadrant. So what reduction formula am I going to use in the third quadrant? There we go, Ria Betsway. So in other words, I am going to write 225 as 180 plus the difference between 225 and 180, which would be 45 degrees. Okay, so I am going to write cos 225 as cos 45, but, there's a big but here. Okay, my ratio is not going to be positive. Okay, it's going to be written as negative cos 45. So we need to talk about that. Why is our ratio negative? Okay, and that is because when we are in the third quadrant, we interpret cos theta as x over r, but x is negative in the third quadrant. So if I've got the cos of 180 plus an angle theta, okay, because x is negative in the third quadrant, this is going to end up being negative cos theta. Okay, because our x is negative and cos theta is x over r. Okay, so it would be negative x over r. Right, that's why it would reduce to a negative. But again here, Ria Betsway, can you see that 225 has been reduced, made smaller, and it's been written in terms of an acute angle. Okay, that's the purpose of reduction formula. The word reduction or reduce in English means to make something smaller. So we're taking angles that are bigger than 90 and we are writing them in terms of an angle between 0 and 90. That's the purpose. Okay, why are we using quadrant 3? Tembelihle, because 225 degrees lies somewhere between 180 and 270. That's why. So our terminal arm would have come to rest somewhere in the third quadrant. Okay, because 225 is between 180 and 270. Does that make sense? Yes, Ria Betsworth. It's always to make it into an acute angle. That's the idea. Okay, 100%. All right. So let's just go back here and go and talk about these reduction formulae. Okay, so we're working with sine, cos, and tan of an angle. So if we are working with the sine of 180 minus theta, okay, the sine of an angle. The sine of any angle is y over r. So here, this is going to be positive y over r. Okay, because our y coordinate is positive in the second quadrant. So this is going to reduce to positive sine theta. If I'm talking about the cos of 180 minus theta, cos theta is x over r. Okay, so remember always, let's just put here, sine theta is y over r. Cos theta is x over r. Tan theta is y over x. So we need to know this. I don't know if any of you have learned this at school, but there's an acronym that can help you remember that. Okay, so it goes like this. So sine theta is y over r, cos theta is x over r, and tan theta is y over x. Sorry, let's write that as a normal x and not a cursive x. Okay, so it goes like this. It goes shade your rear. So see here, SYR, cos X rays. So CXR. And then the last bit here, tan your exterior. Okay, so TYX. All right, if you are forgetting how to do that. Just, sorry, Yolanda, just give me 1 second. My cat is howling. He wants to get out. I just need to open for him because I can't concentrate with him yelling in the background here. I'll be 2 seconds. Sorry.
No, that's perfect. Kamogelo, do you have a question? You can unmute and ask.
Hi, Yolanda and everybody.
Hi.
So on the part where Ma'am was explaining that the cos 180 degrees plus 45 degrees is gonna be our cos is gonna change into being a negative cos 45, right? So I wanted to add the fact that we can actually do this thing they taught me at school, that in the first quadrant, all of them are positive. And then in the second quadrant, sign is positive. And then in the third quadrant, tan is
Tan is
positive.
positive, yes.
Yes. So meaning all the other ones in quadrant number 3 are negative. So I'm saying that we could use that. We know that in third quadrant, the only one that's positive is 10, and then all of the other ones are negative. So we can say, since it's in the third quadrant, since we're using third quadrant, cos in third quadrant is gonna be negative.
Quite right.
Well
Quite
done.
right. Yeah, absolutely. So this is the cos diagram, and it comes from these reduction formulae that we were just talking about here. So sine theta, as you were saying, is positive in the second quadrant. So when we do cos 180 minus theta, we end up with negative cos theta because x is negative in the second quadrant. Similarly, if we're talking about the tan of 180 minus theta, because x is negative in the second quadrant, this is also going to reduce to negative tan theta. So that's where you get the A for all and you get the S for sine theta being the only one that's positive in quadrant number 2. So yeah, thank you because that's actually exactly what I was heading on to. Okay, thank you for saying that. So similarly, if we say sine 180 plus theta, this reduces to negative sine theta. If we say cos 180 plus theta, this reduces to negative cos theta. That's because both x and y are negative in the third quadrant. And if we're talking about the tan of 180 plus theta, we would end up with negative y over negative x, which would give us positive tan theta. Our ratio would be positive. So that's where the t comes from in the cost diagram. Okay, and then the last one would be 360 minus. So if we were talking about the sine of 360 minus theta, that would reduce to negative sine theta because y is negative in the fourth quadrant. If we're talking about cos 360 minus theta, it's going to reduce to positive cos theta because x is positive in the fourth quadrant. And tan 360 minus theta, that would reduce to negative tan theta, okay, because y is negative in the fourth quadrant. So absolutely, this is what
I can't mute. Sorry. Okay. Sorry, I couldn't mute Dumelo. I don't know why. But I just muted all of you now. So teacher Lee, please unmute. Because I
There we
couldn't,
go.
every single time I clicked that button, it didn't mute. Then I didn't
Oh,
understand what's
okay.
going on.
All right, there we go. All right, so we're all back on track now. Everything's fine. So yes, that is exactly right. That is where our cast diagram comes from. Okay, so now, hang on. Ma'am, could you please show us that schedule thing again? Yes, absolutely. I'll go back there now. All right, so Tsegofatso, can't I just type in? Okay, but you see, the thing is that you can't work in terms of a letter on your calculator, Tsegofatso. Okay, so you have to learn these reduction formulae. Okay, so if you're talking about numbers, then yes, but if you're working in terms of theta or x or another variable, then you're not going to be able to put that into your calculator. So that's why you have to learn your reduction formulae. Okay, so just back to this. All right, so there's the shade your rear because x-ray is tan your exterior. So that's just a way for you to remember that the sine of an angle is y over r. The cos of an angle is x over r. The tan of an angle is y over x. Okay, so there we go. All right, I hope that was long enough. Jade, all right. Now, so how were you saying, ma'am, what about cos ratios? What do you mean, what about cos ratios? What are you referring to? What are you referring to, Sihawu? Okay, I'm going to carry on, and then Sihawu, if you want to jump in, then you're more than welcome. Okay, now, the other thing that we need to mention, all right, is 90 minus and 90 plus. Okay, so 90 minus theta means that our terminal arm has gone up to 90 and then it's come theta degrees back in the opposite direction. So it's gone 90 degrees in an anti-clockwise direction and theta degrees in a clockwise direction. So 90 minus theta is another way for us to describe the size of an angle in the first quadrant, right? Another way for us to describe the size of an angle in the second quadrant is to go 90 degrees plus theta. So here our terminal arm has gone up to 90 and then it's gone plus theta degrees so that it ends up being in the second quadrant. Remember, when we're talking about theta over here and in our reduction formulae, all of these angles theta are going to be acute angles. Okay. Sorry, let's just have a look. Excuse me, ma'am, about the acronyms. Are they the same as SOHCAHTOA? Yes, Yanela. So SOHCAHTOA was what you used in grade 10. Okay, so SYX is the grade 11 and grade 12 version of SOHCAHTOA. Okay, yeah, you don't use SOHCAHTOA in grade 12 anymore. Quite right. Okay. Yes. So see how that's exactly what I'm talking about now is your co-ratios, 100%. Okay. So 90 minus and 90 plus. So 90 minus theta is quadrant 1 and 90 plus theta refers to quadrant 2. All right. So the only ones that you learn about are sine and cos. All right. So you can have the sine of 90 minus theta and you can have the cos of 90 minus theta. Incidentally, if they do give you the tan of 90 minus theta, what you would do here is that you would use your tan ratio from grade 11. So do you remember tan theta was equal to sine theta? I don't know why my pen does this sometimes, but it's very irritating, is equal to sine theta over cos theta. That was our tan identity from grade 11. So if you did see tan 90 minus theta, you would write that as sine 90 minus theta. Why am I doing that? As sine 90 minus theta over cos 90 minus theta. Right, and then you could simplify it further. All right, so the sine of 90 minus theta reduces to cos theta, and the cos of 90 minus theta reduces to sine theta. So if we applied that over here, we would end up with cos theta over sine theta. Okay. All right. So those are our co-ratios in the first quadrant. In the second quadrant, again, same story. We can have the sine of 90 plus theta. So sine 90 plus theta. This reduces to positive cos theta. And we can have the cos of 90 plus theta. And this is the odd one out. It reduces to negative sine theta. Okay. Now, it's all good and well me telling you that sine 90 minus theta is cos theta and that cos 90 plus theta is minus sine theta. Do we know why this happens? Yes, in Nkuniza, it is, but 90 plus theta will change sine to cos and cos to sine. 180 minus theta doesn't do that. So if you've got the sine of 180 minus theta, it reduces to positive sine theta. If you have got the sine of 90 plus theta, it's going to change to cos theta. That's why we call them co-ratios. Okay, so co as in go together. So actually, did you know this? All right. Let's just clear some more space over here. The word sine theta, this SIN is actually an abbreviation for the word sine like that. And cos theta, so cos theta is an abbreviation for this, cosine. Okay, so we abbreviate sine to the first three letters and we abbreviate cos to the first three letters. That's why they are co-ratios. Sine and cosine, they are co-ratios. Do you know what it means when they talk about co-ratios? Do you know what they're referring to, what they mean by co-ratios? Does anybody know? No, okay. So it comes from this. The best way for me to explain this to you is to use a right angle triangle. Okay, so let me draw a right angle triangle over here. Okay. Right. If I call this angle over here theta, okay, how big is the other angle over here where I've just put a little black dot? How big is that angle in terms of theta matrix? Yes, those are the only co-ratios that we have to learn about. There we go. There we go, Ovio. There we go, Cabello. Well, not A, but theta. Yes. So this angle over here, in terms of theta, this angle here is going to be 90 minus theta. Does that make sense to everybody? It's okay, Cabello. You know how many mistakes I've made in my lifetime. Lots and lots, I can assure you. Does that make sense to everybody? That this would be 90 minus theta? No. Okay. So, Katleho, let's pretend that this angle over here is called x. So we would say that x plus 90 plus theta adds up to 180 degrees because of the angles of a triangle. So remember, we are trying to solve for x here. So if I take these two terms over to the other side, it would be 180 minus 90 minus theta. And that's why that angle that we've now called x would end up being 90 minus theta. Okay, so 90 minus theta is an angle inside a triangle. It can be seen as a reference angle. So let's say I decide to use a 6, 8, 10 triangle. Okay. If I asked you for the ratio of cos theta matrix in relation to this diagram, what would you tell me cos theta is equal to in terms of numbers? There we go, 8/10. Good, well done. Okay, so in baby language, using SOHCAHTOA, adjacent over hypotenuse. Perfect, right? Now let's change our reference point, okay? So let's talk about the sine of 90 minus theta. Now I'm not referring to this angle anymore. Now I'm referring to this angle over here, okay? This is now my reference angle, 90 minus theta. What is the sine of 90 minus theta? Exactly. It's the same thing, isn't it? It's also 8/10 because remember, the sine of any angle is, again, baby language, opposite over hypotenuse. Okay, so this is where we get our co-ratios from. It's from this. How we prove 90 plus theta is a little bit different. We have to do that on the Cartesian plane, but we can explain theta and 90 minus theta using a triangle. So if they're both equal to the same thing, then it stands to reason that they must be equal to one another. That's why the sine of 90 minus theta is equal to cos theta. That's where it comes from. Okay, Kamogelo, you got a question?
Ma'am, could you please explain how we got the sine 90 degrees minus theta again? Because um I I think there's something we should do before that. I'm not sure.
Okay, so you mean how I got 90 minus theta? Okay, so
No, I mean, like, you see, we have sine 90 degrees minus theta. So let's say we were given that in an exam. Do we just go ahead and write that it's 8/10?
No. I'm just showing you why the cos of 90 minus theta is equal to 8/10 for this particular diagram. If they asked you for the sine 90 minus theta in an exam, they'd want you to write that as cos theta.
Oh, okay. That was my
Okay. All right. No,
confusion.
that's what they'd want you to do. So they'd want you to use your co-ratios, your reduction formulae. So in other words, if they gave you, so it's these ones over here that you're using. Right, so if they gave you the sine of 90 plus theta, you'd write cos theta. If they gave you the cos of 90 plus theta, you'd write minus sine theta. If they gave you the sine of 90 minus theta, you'd write cos theta. If they gave you the cos of 90 minus theta, you'd write sine theta, and then you would proceed from there. Okay, that's what it is. That's what they're expecting from you.
All right. Thank you, ma'am.
Okay. All right, no problem. All right, so we're almost finished with the Cartesian plane. There's just one more thing that I need to talk about apart from the co-ratios. The other thing that we need to think about is our negative angles. Okay, so we are expected to be able to reduce those as well. Okay, so what I'm referring to is this. If they give us something like sine minus theta or cos minus theta or tan minus theta. Okay, we need to understand what that means. And that goes back to what I was explaining in this bit of the diagram in the beginning. Okay, so in other words, our terminal arm is not moving from lying on top of the x-axis into the first quadrant. It's moving in the opposite direction. It's moving into the fourth quadrant. So we interpret sine minus theta, cos minus theta, and tan minus theta as meaning that the terminal arm has come to rest in quadrant 4. Okay, so in quadrant 4, only cos theta is positive. So this would reduce to negative sine theta. This would reduce to positive cos theta, and this would reduce to negative tan theta. Okay, is everybody all right with that as well? Any questions? Yes. Okay. Ria, go for it. You're welcome to unmute and speak.
Ma'am,
Hi there.
ma'am, I wanted to ask, are those all the coefficient ratios, just sine and cos? They're the only two that complement each other.
That you need to worry about in caps for now, yes. In the old syllabus, in the old higher grade, we had to worry about reciprocal ratios as well. But as far as you are concerned, yes, those are the only two you have to worry about. Tan and its reciprocal are also seen as co-ratios, but you don't have to worry about that in the cap syllabus. It's just sine and cos. Okay. All right.
Thank you,
Ola,
ma'am.
no problem, Ria Betswe. Okay, so Ola asks, ma'am, is the terminal arm when negative always going to be in the fourth quadrant? Not necessarily. You see, it depends on how big theta is. If we're writing it in terms of sine minus theta, cos minus theta, tan minus theta, then that angle is no smaller than negative 90. But if I write something like this, Ola, if I write the cos of minus 120 degrees, am I in the fourth quadrant? No, exactly. Exactly. Now I'm in the third quadrant. Does that make sense to you, Ola? So here, okay, just because it's the cos of a negative angle doesn't mean that it's going to reduce to something that's positive. All right. So when I write it in terms of a letter or a variable, then the implication is that it is going to be cos minus theta is going to reduce to cos theta. But if I actually know an angle for theta, then I've got to be careful, because if it's smaller than negative 90, then your ratio is going to be negative because you're not going to be in the fourth quadrant anymore. Okay, Kagiso, do you want to ask a question?
So, ma'am, what if it gets reduced more than like 120, or like it gets reduced by 180, but it's sine, ma'am, and it
Okay,
like lands in the second quadrant?
okay. So if we're talking about the best way for you to understand something like this, sine minus 180, is actually to think about it in terms of your graphs. Okay. And that's why, like, I mean, teachers can't possibly teach the graphs at the same time as they teach everything else, because it would just be way too confusing for students. But just think about your sine function. Okay, so if you recall from grade 10 and grade 11, this is what your sine function does, doesn't it? If you can remember that. Okay, so you had a maximum here of 1 at 90 degrees. Okay, there's sine 180. So it's going to end up being 0. Okay, so it doesn't matter which way you get to your answer. Sine minus 180 literally means that the terminal arm was anchored here at the origin. It swung 180 degrees in a clockwise direction, and now it's come to rest over here. So what is the value of y anywhere along the x-axis? It would be 0. Okay, so oopsie, sorry, I've written the wrong, didn't mean to write the degrees. It would be equal to 0. Okay, does that make sense? Sort of, no. Okay, where have I lost you guys? Okay, let me explain it like this, okay? If you are talking about the graph y equals sine x, what are the x's? What are the x values? The x's are our Our angles, exactly, Kagiso. They are our angles. Okay, so if I write the sine of 30 degrees, okay, 30 degrees is my x. What it's equal to is my ratio or my output on my function. Okay, so it would be equal to a half. All right, so if I find 30 degrees over here and I go up here and I read off there, I would find that that would be equal to 1/2. All right, so if I write the sine of 180 degrees, or I write the sine of minus 180 degrees, it's exactly the same thing, okay? What you could do if you wanted to is you could look at the sine of minus 180 degrees like this. Let's extend our graph backwards, okay? Our pattern continues to repeat itself. So it goes down and then it goes up and then it goes down again. Over here, this minimum is at negative 90. Over here, it's equal to minus 180, right? So at that point over there on the x-axis, that's where x is equal to minus 180. What is the corresponding y value? It would be equal to 0 because it's now on the x-axis. Does that make more sense to you? Well, 30, 45, 60, and 90 are seen as special angles. Minus 180 is not seen as a special angle. Right, but the sine of 180, you can look at it as, if I say the sine of 180, then essentially what I've done is I've gone like this. Okay, so I was at 0, I'm still at 0 in terms of y. Or if I said minus 180, then I'm just swinging in the opposite direction. So that would be plus 180 degrees. And on the Cartesian plane, that would be minus 180 degrees. I'm still going to end up with my output or my ratio being equal to 0. So Nizole, you've said sine is sine is positive in quadrant 2 because it's 180 minus theta. So if the angle were, so Nizole, you're onto something here, okay? So if you said the sine of 180, absolutely, you could look at it as though it was the sine of 180 minus 0 degrees. Okay, so that would be the sine of 0 degrees, which would be 0. You could look at it like that if you wanted to. Okay. How are we feeling right now? Thumbs up, thumbs down for the most part. Are we okay? We're getting somewhere. Oh, good. Okay, up and down. Absolutely. So it's very difficult, I suppose, if you were lost in Trig in grade 10 and grade 11. I mean, essentially what I'm doing now is a revision of everything that you've learned in Trig in grade 10 and grade 11, but I'm doing it in 1 hour. Okay, so that is very difficult. Okay, I think probably the best thing for you guys to do is see if you can try and watch the video again before we move on to the next thing, because all of these concepts from grade 10 and grade 11 are important for us before we can move on. If we don't understand the basics, it's going to be very difficult for us to try and apply any of this to what it is that we're going to be doing. Okay. Oh, good. So you did mute. Okay, there we go. Sihawu, yes, I guess you can. You can. I mean, if you did that now, Sihawu, and you went sine 180, what do you get as an answer on the calculator? Can you unmute, Sihawu? Exactly. Okay. Hello.
I get 0 when I put it in the
You
calculator.
get 0. Okay, and now do sine minus 180. What do you get?
I get 0.
You get 0 as well. Okay, absolutely.
Thank
Okay,
you.
so no problem. Okay, so you would get that if you put it in the calculator as well. All right.
Ma'am,
Yes, Kamogelo.
the part where you said sign in on our calculators,
Mm.
for me, it's not giving me a 0. It's giving me like 0 comma something. So do we
Okay.
convert it all?
No. Okay, so what you've got to make sure is that when you are doing trig in high school, make sure that your calculator is set on degrees and not on radians. Okay, so be very careful about that. How would you have a Casio? How do you have a Casio calculator? Yes. Okay. All right. So this is what you're going to do. Okay. I want you to press Shift 9. What does that bring up on the calculator when you press
It's,
Shift 9?
it's clear, the setup, memory, and all.
Okay. So 3 is all, isn't it?
Yes.
Okay. So press 3, then press equals, and then press the AC button.
Yes.
Okay, now what you should find is that in the very top part of your calculator, there's a tiny little capital D.
Yes.
Yes. Okay, now I want you to work out the sine of 180 degrees again.
0.
There we go. Okay, so all matrics, make sure when you are doing trig, especially when you're writing tests and exams, clear your calculators, reset them so that it is on degrees and not on radians. Okay, because if you've got it set on anything else by accident, you're not going to get the same answers. Okay, all right, so there we've sorted that one out as well. Are there any other questions you guys would like to ask me about the Cartesian plane and reduction formulae or co-ratios before we move on? Yes, Kamogelo. Please unmute and speak.
Ma'am, could you please
Yes.
scroll down? Right here. The
Okay,
part where
yeah.
you were explaining the y is equals to sine x, and then you asked us what the x is for.
Mm,
I didn't understand what were we figuring out? What were you
what were we
explaining?
doing? Okay.
Yes.
All right. So what I was trying to, no problem. So what I was trying to explain to you here is that when we look at trig graphs, okay, our trig graphs are related to what we are seeing on the Cartesian plane. Okay, so I tell you what, let me go down here. All right, when you look at the Cartesian plane, and we have 0 here and 90 here and 180 here and 270 here, that is one perspective. All right. When we are looking at a trig function, okay, so there's y, there's x, there's y, there's x. Your trig graph, if you recall from grade 10 and grade 11, does this, okay? Over here, this is equal to 90. Over here, that's 180. Our minimum is at 270. And here we've come back to 360. So 0 degrees is here at the origin. 90 degrees is over here. 180 is there. 270 is here. 360 is back there. So in other words, when we look at it from this perspective, if I draw a line down here, This is quadrant number 1, just like this is. Between the green line and the yellow line, this over here is quadrant number 2. Between the yellow line and the blue line, there is quadrant number 3. And between the blue line and the pink line, there is quadrant number 4. Okay, so when we say to you that sine theta is positive in quadrants 1 and 2, it's because your graph is above the x-axis where y is positive. So that's why if I say y equals sine x, this is what is positive in quadrants 1 and 2. Okay, that's why when we work in quadrants 3 and 4, we end up with negative values. Okay, because the graph is below the x-axis where y is negative. All right, so what's important to know when we're working with functions or on the Cartesian plane, x are our inputs. These are our angles that are going in. Y is our outputs. These are our ratios. Okay, so if I say to you sine x equals a half, all right, I am saying that the output or the ratio is equal to 1 over 2. Does that make sense?
Yes, it does, ma'am.
Okay, so I think this is a really nice way of being able to look at it as well. Okay, and to see our ratios as outputs and our angles as our inputs, because of course what we're doing on the Cartesian plane and what we're doing in our graphs is the same thing. So essentially what we are doing is that when we look at it in the Cartesian plane, we're looking at it like a bird looking down on the earth from a bird's eye view. When we're looking at a diagram over here of our graph, we're kind of looking at this information from the side. Okay, so it's 2 different perspectives of the same thing. Okay, does that feel a little bit better about when I'm saying y equals sine x or y equals cos x? Okay, so again, if you consider your cos function, just very quickly now, because we did start a couple of minutes late. Let's just draw that quickly. Okay, so there's our x-axis, there's our y-axis. If you recall, guys, your cos function did something like that. That's not the best drawing in the world, but there we go. So this, if you recall, was 90, wasn't it? And over here, our minimum was at 180. We had another x-intercept at 270 and a maximum over here at 360. So again, if I use different colored lines to separate the quadrants, there's quadrant 1. Here's quadrant 2. Here's quadrant 3. Here's quadrant 4. Okay, so if I say y equals cos x, we were saying in the beginning, okay, cos is positive in quadrants 1 and 4. Look here, guys, can you see how the line is above the x-axis in quadrant 1 and quadrant 2? Cos theta or cos x is negative in quadrants 2 and 4. Okay, that's where the line is below the x-axis. So y is negative. Do you see how it all ties together?
Yes.
Okay, so I think seeing it from this perspective really kind of helps us to understand the Cartesian plane together with our graphs. Okay, I hope this makes a bit more sense to you as well. All right, so Mihlali, let's just have a look. And you've also asked. Okay, so to have sine to be, okay, all right, so first, let's just go back up here. Okay, Mihlali, do we always change cos and sine? Mihlali, only if you're using 90 plus and 90 minus. Okay, if you're doing 180 minus or 180 plus, then you're not going to say sine is cos and cos is sine. Okay, Tsagofatso, you've question relating overall to the topic of trig. Do you think when we'll be able to finish? When do you write your formal test, Tsegofatso? Just pop that into the chat for me because I'm going to do compound angles with you on Thursday and then again on Tuesday. Okay, so Sibonga Konke, again, sine and cos only change when we're working with our co-ratios. Okay, so in do sine 90, sine is cos theta, cos 90 minus theta, sine 90 plus theta equals cos theta, and cos 90 plus theta equals minus sine theta. Yes. Are these the only cofunctions we'll use this year? Indomiso, non-domiso? Yes. What you've said there is true. Okay, Metlali, when we tap this into the calculator to be able to plot the graph, do we always use 90 as our start? No, you're starting at 0. Okay, I just didn't write 0. Okay, Metlali, but both of these graphs start at 0. Okay, so the origin, here's the origin. Okay, over there, there's 0 degrees. So this is 0 degrees. This is 0 degrees. Okay. Katleho, I'm going to take your question now. Next week, Wednesday. So yes. I would have finished compound angles with you. I would have done the basics and stepping up. Okay, Tsegofatso? Yes, Cabello. So I'm going to explain to you before we start compound angles. I'll explain to you exactly what a compound angle is. Okay, and what it means. And then we will look at our compound angle formulae and how we use them and apply them in trig expressions. Okay. Any other final questions before we say goodbye? How's everybody feeling about the revision that we've done? Are we okay? Thumbs up, thumbs downs?
Yeah, let us know. There we go. I've reached 100%.
Okay, brilliant. Okay,
Been waiting
Katleho,
for that.
that's perfect. Katleho and Ola have got questions as well. Getting there. Okay. All right, but then some thumbs ups. Good. Okay. All right. Well, that's nice to hear. Okay. And Bali up and down. Okay. All right. Katleho, what's your question?
Hi, ma'am. Hi, everyone. Ma'am, I just wanted to say, I'm not sure if you said it because, like, I was not necessarily paying that much attention because it was revision. I'm sorry, ma'am. But, ma'am,
That's so
I love
sweet.
the apology.
I love that. Oh,
okay,
Katleho,
ma'am.
carry on. That's fine.
Ma'am, I couldn't help but realize, ma'am, when you explained with the graph, these two graphs, ma'am, the whole 90 plus and 90 minus makes sense because, ma'am, when you move this
Yes.
one of the graphs with just one quadrant, it actually makes another shape, which, like, I don't know if that makes sense,
No,
ma'am.
Katlego, you're absolutely 100% correct. So in other words, what you are seeing here is that if you go back and have a look, and I'm sorry that everybody else is gone already, but I mean, we are over time. If I was to extend that a little bit further this way, there is your cos graph. So your cos graph is this bit over here. Your sine graph and your cos graph are identical shapes. They are just 90 degrees separated from one another, for want of a better word. So you can see here, if I was to take my cos function and shift it 90 degrees to the left-hand side, I would have a cos graph. And if I was to take my cos graph and shift it 90 degrees to the right, I would end up with a sine function. So yes, that's why we call them cofunctions. Okay, you are onto something there. That is absolutely right. I'm so glad you were able to see that, Katleho.
Yes, ma'am. Okay, ma'am. Thank
Okay,
you.
100%. Well done. Okay, no problem. And then Ola, your question.
Evening, ma'am.
Good evening, Ola.
Ma'am, I have a question. In terms of in a test, let's say we're given an interval and we have to like draw a graph. Will we have to like start at the interval that we're given
Yes, you would have to work in the interval that you were given. Yes.
Oh,
Yes.
okay.
Yes, you would. You
Okay,
would.
thank you.
The good news is, Ola, we will talk about trig graphs later on in the year. We're just talking about general trig at the moment. But I think it's important by the time we get to grade 12 to understand our cast diagram together with our trig functions. The good news is that as far as the trig functions are concerned, you don't really learn any new work. So it really is just the same as grade 11. They just kind of ask some sort of slightly more difficult questions, like for which values of x is the graph increasing, or for which values of x is the graph decreasing, or for which values of x is the graph is y negative, or stuff like that. So yeah, it's pretty much exactly the same work. Okay, Ola, but we'll revise that before you write your exams.
Okay, thank you very much, ma'am.
No problem. No problem.